let's go ahead and look at problem number 3 of section 5. We're going to use special triangles to find area. Okay, so we have a honeycomb, and it's made up of regular hexagonal cells. So that means we're looking at 6 sides. Okay, so n equals 6. The length of a side is 3. So then what would the perimeter be? Would that be 18? And what is the area of this cell? Well, the area equals 1/2 the apothem times the perimeter. Well, we know our perimeter is 18, and we have the 1/2, but what is a, little a? That'd be the apothem, right? So that's from the center to the edge. We'll see here we're putting together both the two previous things, problem number 1 and problem number 2. So we know that the distance here and all of these are all the same, right? Didn't we find all those by just taking 360 and dividing by n, and our n is 6. So that's 60 degrees, right? So that means, let me draw maybe a bigger one. That's probably bad, but that's okay. So we know from here to here, this angle is 60 degrees, okay? And then we have the apothem that always goes down from the center, and it bisects that 60, right? And creates a 90 degrees right here. So if it bisects 60, isn't this angle 30? So if that's 30 and this is 90, what is this corner one right here? Isn't that got to be 60 then? So then I have this special right triangle, which we've talked about in the last section, a 30, 60, 90. And we're trying to find this apothem right here, this distance, right? So if I have a 30, 60, 90 triangle, can I find this distance? And I know that this full length right here is a distance of 3. So if I know the full thing is 3, what also does this apothem do to that side? It's a perpendicular, yes, but what does it do to that side? Remember I said it cuts it in half, so that's 1.5. So this length right here is the same as this one, and it is 1.5. So this distance right here is 1.5. So this is 1.5. So is there any way we can use section 7.3 or 7.4 in order to find this apothem right here? Well, can I use either opposite if I'm talking about the 30 and adjacent, which is tangent? So can I use tangent of 30 equals opposite over adjacent? And I could flip that fraction and have 1 over 1.5 equals 1 over tan of 30. Or basically these can just switch positions. Remember from our proportions, we can just switch those for proportions. So then we have apothem equals 1.5 over tan of 30. And so we can enter that in, and that will give us our apothem. And once we have our apothem, we can stick it right here and solve for that. Or I could use the 60 and did opposite over adjacent. So I could have did tan of 60 equals opposite over adjacent. And then I have to just multiply 1.5 times tangent of 60 equals a, where this is tan of 30. Okay, this is probably easier to type in your calculator, right? So either one of those is going to get us the same answer, and that's our apothem, which is about 2.6. So this equals 2.6. So then I can plug it in here, or 2.6. And now I can just multiply that 1/2 times 2.6 times 18. And so that equals 23.4. And square millimeters. Okay, so there's our answer. And so that's how you do it. You could also take 2.5 times 0.5 times 18. That's, or 2.6 times 18 times 0.5. Remember, timesing by a half is like dividing by 2 or timesing by 0.5. Okay, so there's our answer for that. So first what I had to do was I had to create this special right triangle. Because I have 6 sides, that means this is going to divide evenly into 60s, and then that apothem cuts that in half to 30. And so what about you? You have a regular hexagon shape that is 16 feet. What's the area of this hexagon? Okay, so you're going to do the same thing. You're going to have this special right triangle, right? This whole thing would be 60, so this one's going to be 30. So what is this corner going to be? And then you can apply your trig functions in order to find this apothem, this distance right here, right? That apothem, because you need to find that apothem in order to times it by 0.5 in order to, and then your perimeter, right? And then you get your area. Okay, go ahead and try your best on that one. And that's it for chapter 7.